In this tutorial, we'll run the average nearest neighbor index, or ANNI, on a point pattern using Q-GIS 3.2.3. In QGIS, this tool is called the nearest neighbor analysis. Our point pattern is a layer with 42 points, each representing a biting fly trap location on a study ranch, indicated by the polygon boundary. The ANNI is a global spatial clustering statistic, meaning it will indicate if the trap locations are random, dispersed, or clustered on the landscape. In this example, such a test would be useful to know if the traps are clustered ahead of using trap data from these sites to test for clusters of fly counts collected at these locations. When running ANNI in QGIS, the extent of the landscape considered for the analysis is represented by a bounding polygon, shown here in red, capturing the area contained within the outermost north, south, east, and west points in the dataset. A previous video on this channel describes the ANNI calculation in detail. Here we'll focus on performing the test, so let's get started. The tool is located under the Vector pull-down menu under Analysis Tools, Nearest Neighbor Analysis. This will bring up a dialog box to populate the parameters of the test. In QGIS, this is limited to identifying the input layer. Here, we'll use the trap CPUE layer, which contains the trap locations. The ANNI requires area for the calculation, and that is derived from the bounding polygon automatically. In ArcGIS or in an R script, you could select the area of the study polygon if desired. The output from this analysis is numerical and will be saved as an HTML file. You can select the directory path for the output and name it, and then run the analysis. Once the analysis is complete, we can access the results in the Results Viewer here in the bottom right of the screen. There's an active hyperlink to launch the results. Clicking it will launch your default HTML viewer. Here, my computer launches Google Chrome. Here we can see our observed mean distance, our expected mean distance, and our nearest neighbor index. We also see a repeat of our sample size, 42, the number of fly traps available in the dataset, and a z-score. Our ANNI value is 0.935 or nearly 1, which indicates a random pattern with a non-significant z-score. From this analysis, we can conclude that the biting fly trap locations were not clustered or dispersed and are spatially random. Here's a simple table we might construct in Excel or another spreadsheet editor to display these values for our reader. Alternatively, we may also just write a sentence in the results section describing these same values.